this video, we're going to take a look at probability and what can happen during an event, and then what are the chances of that happening. So when we're looking at probability, we want to understand some key vocabulary words. And some of the things we need to understand are what are outcomes and what are events. So when we're doing an experiment that has different possibilities of what could happen, this could be something like spinning a spinner, rolling a die, flipping a coin, drawing marbles out of a bag. The first thing we want to talk about is what is possible. And whatever is possible is called the outcomes. So let's say that we're flipping a coin. And so the possibilities are that it could land on heads or it could land on tails. So we would have two outcomes. When we're doing a probability experiment, we call that experiment the event. The event is each instance that is occurring. So for example, if I'm flipping a coin, every time I flip the coin, that would be an event. When we're doing an event, we want to look at what do we want to happen. And what we want to happen is called a favorable outcome. So let's say I'm flipping a coin and I select heads. So that means the favorable outcome would be heads, because if heads comes up, then I win or I get what I wanted. And so when we're looking at probability, we're going to be looking at what can happen compared to what we want to happen. It's going to be a ratio. Okay, so let's start talking about what are some types of events that we can calculate probability of. So if we're rolling a number cube is what we often refer to as a die, and we want to think about what can happen. These are the possible outcomes. So when I roll a number cube, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So there are 6 different possible outcomes. If I'm asked to list out the outcomes, I would want to list out everything that could happen. A favorable outcome is an outcome that would be the desire that I want. So let's say I would like an even number. So that means rolling a 2, a 4, or a 6 would be considered a favorable outcome. If I wanted to roll a number greater than 5, the only favorable outcome would be a 6, because 6 is the only number on my number cube that is greater than 5. If I'm looking at a spinner, same situation. I want to look at what can happen compared to what I want to happen. So looking at this spinner, we want to look at, it's labeled 2 different ways. We have both colors and numbers. So we want to look at how many ways could the spinner land on red. So it could land on this red, or this red. So there are 3 possibilities of landing on red. If we wanted to look at how many ways are there to not land on orange, they're referring to this as orange, I would want to count all the spaces that are not orange. So this one here is not orange. This one here is not orange. 3, 4, 5, and 6. There's 6 spaces that are not orange. And what are the favorable outcomes of spinning not orange? Well, we can see that we have red, and there's 3 of those. And we have blue, and there's 3 ways to get a blue. So we have 6 possibilities that are not orange. Now that we understand what can happen, what our outcomes are, and what we want to happen, what a favorable outcome is, we're ready to start looking at how to actually represent probability. And so probability is a number that expresses how likely something is to happen. So it could be we're doing an experiment and we're actually keeping track of what's happening, or it could be we just want to know what is the likelihood that something could happen. And we find probability by comparing the favorable outcomes, what we want to happen, to what is possible. What is possible we call our sample space. And on the previous slide, that's the outcomes that we saw were possible. And so if I'm flipping a coin, my sample space is it could land on heads or it could land on tails. If I'm rolling a die, I could get the numbers 1 through 6. So to find the probability, I'm going to set up a ratio that compares how can what I want to happen compared to what is possible. So our favorable, what we want, compared to the total outcomes, what is possible. Okay, so probability is often referred to as, is it likely or unlikely? So if we're thinking about this as like a number line, right? Something that is unlikely is never going to happen, right? Something that is 50-50 is right here in the middle. And then if it's on the right side of that blue line, it is likely. So anything over here would be considered unlikely, so less than 50%, and anything over here would be considered likely. All right, so now let's actually calculate a probability. So we want to calculate the probability of winning or losing, and it tells us that a basketball team has a 70% chance of winning. We know that percentages are out of 100. So when we're setting up our ratio, we're comparing what we want, that's the desired outcome, to what is possible. So we want to win, and there's a 70% chance of winning out of a possible 100% chance. So that gives us a 7 out of 10 chance of winning. Now, losing would be the opposite of that. So all of the outcomes have to total up to 1. So if we have a 7 out of 10 chance of winning, that means we have a 3 out of 10 chance of losing, because 7 plus 3 would give us 10 out of 10, which is a probability of 1. Okay, now looking back at our spinner. So we want to look at how many different possibilities are there. So we can see that our spinner has 1, 2, 3, 4, 5, 6, 7, 8 spaces. So this means that our total number of outcomes is 8. Now, when we're setting up a probability, we want to put what we want, or the favorable outcome, in the numerator. So if we want to get a 1, we can see that there's 1, 2, 3 ways to spin a 1. So we have a 3 out of 8 chance of getting a 1. Now, 3 out of 8 is less than 50%. It's less than half. Our 50% would be 4 out of 8. So it's actually unlikely that we're going to spin a 1. It's more likely that we'll spin one of the other two numbers. If we want to look at our probability of getting a 2, we have 1, 2, 3 2s. So that's a 3 out of 8 chance of spinning a 2. And then if we want to look at our probability of spinning a 3, we can see we have 1, 2 3s. So we have a 2 out of 8 chance of spinning a 3. So we can see that the probability for each of these, 3 out of 8, 3 out of 8, 2 out of 8, if we add those up, they total up to 1. And we can see that each of them by itself is unlikely to occur.